And it's 24. Metrics and determinants. So, I said that matrix is a rectangular array of numbers, whether the number is a real number or complex number, in rows and columns. In rows and column. So if you have an arrangement of numbers in the first row, first column, A11, A12, A13, A21, A22, A23, A31, A32, and A33. This means the number is in the first row and first column, first row, second column, first row, third column, and the list goes on and on. So, X and Y being integers, a matrix with row and column is called the X by Y matrix. So if you see a matrix, it is written in rows and column. We have a 2 by 2 matrix, a 3 by 1 matrix, a 3 by 2 matrix, and different matrices. So if you write a matrix like this, matrix A equals to 1, 4, 0, 3, minus 2, and 2. This is an example of a 2 by 3 matrix. 2 by 3, that's you count the row before the column. And this is a 3 by 1 matrix. 2, 0, 4. 3 by 1 matrix. See, now if you want to talk about a 3 by 3 matrix, we have something like 1, 2, minus 1, 0, 4, 5, 2, 7, 6. This is a 3 by 3 matrix. This is a 3 by 3 matrix. Are you following me? So anytime they write a notation of A, I, J, you know the I stands for the row and the J stands for the column. So we want to start by discussing about a square matrix. You see, a square matrix is a matrix which number of rows and the number of columns are equal. If you have a matrix that the number of rows and the numbers of columns are equal, we call it a square matrix. So, square matrix. So, square matrix is a matrix where the number of rows and column are equal. If you look at this 2 by 2 matrix, 2, 0, 1, 4, we have matrix B to be 3 minus 1, 2, 6, 1, 4, 3 minus 2, 3. This is a square matrix because the number of rows and the number of columns are the same. This is 2, 2, 3 is to 3. So any of this matrix, we call it what? A square matrix. Are you following me? Yes, sir. So anytime you have such matrix, You should know that when the number of rows is equal to the number of columns, that the matrix is what? A square matrix. Now let's talk about what we call the null matrix. The singular matrix which the entries is 0 is called a null matrix. So if you have a 0, 0, 0 matrix, whether it's a 2 by 2 or a 3 by 3, but the numbers of the elements in that matrix is 0, 0, 0, that matrix is called a null matrix. For example, we have matrix A, you have 0, 0, 0, 0. This is what we call a null matrix. Now we know a square matrix, we know a null matrix. Now let's talk about what we call the identity matrix. Identity matrix is the leading diagonals is 1. Whether it's a 2 by 2 matrix, the matrix which the entries along the diagonal and the 0 entries elsewhere is identity. That is, what I mean is that identity matrix I equals to 1, 0, 0, 1. This is the 2 by 2 identity matrix. If we have an identity matrix that is 3, it is 1, 0, 0, 0, 1, 0, 0, 0, 1. So this diagonal here is 1, 1. So if they give you any matrix and they say I, should take note that that I is what? Identity matrix, and the leading diagonals is 1, 1. So let's see how we can be adding addition, subtraction, multiplication of matrix. Addition, subtraction, multiplication of matrix. We are talking matrix and determinants. Matrix and determinants. Yes, mathematics. Now, matrix addition and subtraction. Matrix addition and subtraction. So, if you have a matrix A, and also have a matrix B, as a matrix A equals to 1, 0, 3, 2 minus 1, and 4. I also have matrix B, if equals to 3 minus 1, 2, 1, 6 minus 2. And you're asked to find A plus B. Matrix A plus B here, you add up the corresponding value of this matrix. So this is going to be equals to A plus B will now be, you add this with this, this with this, this with this, as it goes. So A plus B is a 1 plus 3, 0 plus minus 1, 3 plus 2, 2 plus 1, minus 1 plus 6, 4 plus minus 2. So that will give us what? This is 4. This is what? Minus 1, 5, 3, 5, 2. That is 2. Is that correct? So if you want to subtract matrix, do the same thing. The row to the row, the column to the column. Now let's see how we can have a 3 by 3 matrix multiplication, addition and subtraction. If you have matrix A, they gave you matrix A. It's a matrix A equals to 3 minus 1, 2, 4, 5, 0, minus 1, 2, minus 3. You have matrix B to be 2, 0, minus 1, 3, 2, 1, 5, 2, minus 2. And the question says find A plus B. You now say find A plus B to A minus B. So you now add up my A plus B. You take 3 and add with you have 5. Minus 1 plus this. Minus 1. 2. Minus 1 plus 2. That will be 1. 4 plus 3. That will be 7. 5 plus 2 is 7. This is 1. This is going to be 4. That is 4. Minus 3 plus 2 will be minus 1. If you add up this, that will be minus 5. Is that minus 5? So if you have that, that's for addition of matrix. So let's see how we can subtract matrix A minus B. Matrix A minus B, this minus this word here, 1. Minus 1 minus 0 is what? Minus 1. 2 minus is 3. 4 minus 3. 5 minus 2. 0 minus 1 is minus 1. Minus 1 minus 5. Minus 6. 2 minus 2 is 0. Minus 3 minus, that would mean minus 3 plus 2. That would be minus 1. So you have that place as minus 1. That is addition and subtraction of matrix. Are you following me? Please, are we together? Now, say you know how to subtract and add matrix. Eh? You don't understand? Eh? Which place? Now, eh? Look at this. If you have matrix A and a matrix B, if you are adding, you know this is a 2 by 3 matrix. Are you getting me? So you add a matrix that if the 2 by 3 is telling with this, that's when you add. You cannot add a 2 by 2 with a 3 by 3 matrix. Just like a kind of a square matrix. Like for example, look at the way I'm asking this square matrix now. Because you add the first with the first, the second with the second. Eh? So like this now, I want to add A plus B. You just add the first with the first, second with the second, third with the third. So this is going to be 1 plus 3, 1 plus 1, 3 plus. Normal adding now, 3 plus 2, 4. That's why I'm breaking it up. But when I come here, I did not do that stuff. I just say 3 for addition, this plus this, 5. I just did the normal adding. Are you getting me now? So, let's see how we can matrix multiplication by scalar. Matrix multiplication by scalar. Matrix multiplication by scalar. By scalar. Example, if you have maybe A is a matrix. If you multiply by scalar, that would be Ka. So let A be the matrix m by n and k is a real number. Then the product of k denoted by Ka is m times n within the entity. Example of that is maybe if you have matrix A. Let matrix A equals to 2 minus 1, 4, 3. And now say find 2A. You are finding 2A. This is a scalar multiplied with the matrix. So is that 2A will now be 2 into A. What is matrix A? 2 minus 1, 4 and what? 4 and 3. So the scalar quantity will be multiplied with all the elements, meaning that this one will now be what? 4. What is there? 8 minus 2 and what? 6. That is 2A. So if you are asked to find 3B, and you are given matrix B, So you're asked to find 3b. And you're given matrix B. Let me say matrix B equals to 2, 3, 4, 1, minus 3, and 6. And they say find 3b. So what do we do there to find 3b? I'm not seeing what you are writing. Are you following me? So if you say find 3b, the scalar multiplication is 3b. So you now say 3 into b, 2, 3, 4, 1, minus 3, and 6. Are you there? So you now multiply, that will now be equals to what? Guess what? 6, 9, 12, and what? 3, minus 9, and what? 18. So, let's multiply matrix and see how it goes. You want to go to what we call matrix multiplication. Normal matrix multiplication now. Matrix multiplication. So, if you have matrix A and matrix A, and it has to find matrix B. So this is matrix A is A11, A12, A21, A22, and matrix B equals to A21, A22, maybe B11, B12, B21, B22, and you're asked to find AB. You have to find matrix AB. What you do is that you multiply the row with the column. So this is what you do. Please look up this with this. That's A11, B11, plus A12, B21. That's this with this with this. Do the same thing here. That's A11, B12, plus A12, AB2. You apply the same thing with the row here. Now what? A21, B11, plus A32, B21. The same thing goes here, which is what? A21, B12, plus A22, B22. Let me show you what I'm talking about. This is just a sketch of what I want to do. If you have a matrix, you have a matrix A. If you have matrix A, and in this matrix you have something like this. A, matrix A equals to 3, 2, 1, 4. Matrix B equals to minus 1, 0, 2, let me say minus 2. Let me put my B here. Minus 1, 0, 2, minus 2. And the question says find AB. Find AB. What you do is I multiply the row with the column. This goes for this. Multiply this with this, so that will be 3 times what? Minus 1 plus 2 times 2. That this goes for this. The row goes for the row, and this one goes for this one. That's this multiplied with this. So 3 times minus 2 plus 2 times 2. First, use one. Now do the same thing with this down. What do you have there? 3 times 0 plus what? 2 times minus 2. Okay? Now when you finish with the up, you now come to this other side and multiply this with this. Now we say 1 times minus 1 plus 4 times 2. Is this what? 1 times 0 plus what? 4 times minus 2. So this place will now give us minus 3 plus 4. This is what? 0, 0 minus 4. This is 1 minus 1 plus 8. This is what? 0 plus minus 8. So if you now multiply out, you're going to have 1 minus 4. This place was minus 1. Okay? 7 minus 8. That's how we multiply that matrix. Let me explain again so that you understand. See. Madam, look up. Hello. Multiply the row with the column. The first row with the first column, second with the second. Eh? Have you seen that? 3 times minus 1 plus 2 times 2. That's, this goes for this. Eh? The same one also goes for this one. So 3 times minus 1 plus 2 times 2. Have you seen that? Eh? Then 3 times 0 plus what? 2 times minus 2. When you finish with the up, you don't come with the down. Eh? 1 times minus 1 plus 4 times 2. You don't come to the next one here. 1 times 0 plus 4 times minus 2. I forgot them there. I got a prayer request. Eh? Okay. So the row goes to the column. Eh? The row goes to the column. The row goes to the column. So 3 times minus 1. Look at what I'm saying. This is multiplication of matrix. You use the row to multiply the column. So first, 3 times what? Minus 1 plus 2 times. Eh? The first goes with the first. Second goes to the second. Yeah? I will. Yeah? All right. Now, when you have this value, I was saying that you multiply 3. See, use the row to multiply with the column. Let me explain again so that you understand, because if you guys don't understand what I'm doing here. Now I want to multiply AB. A times B. Multiplication. This is what you do. Huh? I want to use another one. It seems it's not full up. Now this is what you do. Multiply the row with the column. Huh? This is what we call row. This is what we call column. So this row goes for the column. So this goes for the first, second goes for the second. Are you getting me? If you now fix that value, you see the corresponding value of this multiplying minus 1. The first multiply with the first, second multiply with the second. Look at this. What do we have here? 2 times what? 1. 2 times 1 plus, what is remaining here? Multiply with the second one down. That's the row goes to the column. So minus 1. Minus 1 times 1. I have minus 1 times 2. I still use the same one. I have finished with this row. I use them for this one also. Eh? So what do I do again? The same 2. 2 times what? Plus what? Minus 1 times 5. I have finished with the up. I'm using the down now. What do I do? 0 times what? 1 plus what? Have you seen that? I do the same thing for this side. What do I say? Plus what? That's how it is done. So from that point you have 2 times 1 is what? 2 minus 2 here. This what? 8 minus 5. 0 minus 6. 0 plus 15. Have you seen that? So 2 minus 2 is what? 0. 8 minus 5. 0 minus 6. 0 plus 15. I've been able to multiply AB. But if you're asked to find BA, BA is not the same thing as AB. Because BA, you keep B before you multiply with A. So that's how we multiply matrix. So we got some properties of matrix you need to know. So if you have transpose of a matrix, transpose of a matrix, if you have matrix A, you have matrix A, it will be 3, 2, 1, 4. A transpose will now be, take the row to the column. If this place was the row, you come 3, 2, 3, 2, 1, 4. Have you seen what I'm doing there? Have you seen what I'm doing? You don't understand. What did I do? Just transpose means take the row to the column, take the row to the column. So if you have, maybe I have my matrix A, if it equals to 2, 1, 4, 6 minus 1, 3, 0, 2, minus 3. And you ask to find A transpose. A transpose is just do what? 2, 1, 4. Have you seen that? 6 minus 1, 3, 0, 2. You understand what I mean? So that's what I mean by the transpose of a matrix. Now, if you have let's go with what we call determinants. Determinant of a matrix. Determinant, if you have A to be equals to A11, A12, A21, A22, and you're asked to find determinants. This symbol means determinants. Either you write like this or you write like this, date A. It means determinant. How do we do that? That will now A determinant will now be equals to multiply the subtract from here. That is A11 times A22 minus A21 times what? It's A12. That's what I mean. That's how we do determinants. Example I have, maybe determinant. A equals to 3, 2, 1, 5, and you're asked to find A determinants. It simply means multiply this with this, subtract from that. What's 3 times 5? 3 times 5 minus 1 times 2. Have you seen that? Eh? Professor, have you seen what I'm doing? Eh? Is that? So this we got 15 minus 2 will give us what? 18. So whatever you're doing in determinant, that's a 2 by 2 determinant. But if you're asked to find 3 by 3 determinant of a 3 by 3 matrix, what you now do is that one differs from here. You have this matrix now. Is a matrix A equals to 6, 2, 1, 1 minus 2 minus 1. You have this matrix, and you're asked to find the determinant of a 3 by 3 matrix. Determinant of a 3 by 3 matrix. What you do there is that you assign a cofactor to this. You call this plus minus plus. When you take 6, what you have in that column of 6 and row is not needed. So what you now have will now be what? Minus 2 minus 1, 4, 5. When you now take minus 2, the row and the column is not needed. What do you have? 1 minus 1, 3 and what? Now you take plus 1, the row and the column is not needed. What do you have? Do you understand what I'm doing there? You? I'm asking number. No, I won't have it. Have you done determinant before? What about you? You never done before? Okay, look at this. Do you have this plane sheet? Are you using it? Now this one, look at what I'm doing here. When you want to find the determinant of a matrix, what you do is that you see this 6, 2 and 1 that is up. This number here, we assign in a cofactor. This is what we have in a cofactor. Cofactor is A11, A12, A13, A21, A22, A23, A31, A32, A33. And it has plus, minus, plus, minus, plus, minus, plus, minus, plus. That's how it is always assigned. Are you following me? So in this case now, since we want to talk about determinants, a place of 6 minus 2 is A11, A12, A13. There's always what? Plus, minus, plus. So that's anytime you want to determine the first thing you have write plus, minus, plus, because I'm using that first one. Now when you take 6, 6 is what? Plus. When you take minus 2, minus, that's why I say minus, plus 1. Have you seen that? Now when you take that 6 out, what do you see in that row of 6? Both the row and the column. You don't need it. Have you seen it? When you take this 6, what is in that row and column? You don't need. What is now left?
Minus 2, minus 4, 5.
What do you say? That's what you see, minus 2, minus 1, 4, and 5. Have you seen it? Now when you want to take the minus 2, that row of minus 2 and the column, you don't need it. There's that row of minus 2 and that column, you don't need it. 1 minus 1, 3, 5. 1 minus 1, 3, 5. Have you seen that? Are you following me? Now we now take the 1 plus 1. that row of 1, the row and the column, we don't need. So the row of that 1 and the column, we don't need it. 1, 2, isn't it? Huh? So that's how we roll. So when you now bring this out, you now, the law of determinant states, multiply this, subtract from here. Now if you see me multiply 3 times 5 is 15. 3 times 5, 15 minus 1 times 2. So you reach this level, what you now do is that you now multiply. That will be 6. In the multiply this with this. That's minus 2 times 5. Minus 10 minus into minus 4. Because 4 times minus 1 is minus 4. Minus 2 in the what? 5 minus into minus 3. Because minus minus is minus. Then plus 1 in the what? 4 minus into minus 6. So you know why you have 2 minus there? Eh? The minus of this and the minus of that. So this place will now be 6 into minus 10 plus 4 minus 2 into, what is minus minus? Plus. That place will become 5 plus 3 plus 1 into minus 1 is plus 4 plus 6. So that will be 6 minus 4 minus 10 is minus 6. Minus 2 into 5 plus 3 is 8. Plus 1 into 4 plus is what? 10. When you multiply. So therefore this place my sister will have minus 36 minus, this slash means multiplication. This minus 36 minus what? 16 plus what? 10. So from that level we see you're going to get minus 36 minus 16 plus 10 is minus 6. Then minus 16 minus is what? Minus 42. That is how to find determinant of that matrix. So the determinant of that matrix so let's see how we can find adjoint of the matrix too. So when we now have the corresponding value, let's see how we can find the cofactor of a matrix. Assuming you have matrix A, cofactor adjoint and inverse of a matrix. Now, if we have matrix A, it will be 1, now you want to find the adjoint, the inverse of a matrix. Now, if you're asked to find the cofactor, adjoint, and inverse of a matrix, the first step you do is to know that it's what they call the Aij of a matrix. Like in this case now, you're asked to find the cofactor of this matrix. You know vividly that for this matrix you can find the cofactor, the A11, the A12, the A21, and the A22. Now, just like what I told you, that in the matrix we have, using this one for example now, I want to find A11. A11 cofactor has what we call the minor, which is denoted as Aij, which the Ij stands for the row and the column. So I can always put that plus minus without, so that I will not waste time. So I want to find A11 now. A11, you know, is positive here. If I want to use a cofactor journal, you know, the minus 1 to the power of I plus j, where I is the row and the j is the column. So if I come here, this is A11, A12, A31, A13, A21, A22, A23, A21. So this is going to be a plus, minus, plus, minus, plus, minus, plus, minus, plus configuration. How do you get this plus, minus, plus, minus from here? The row and the column. So if I want to find the cofactor of this, whatever I want to get, I multiply with the cofactor. So for the A11, I need this place, abi? So the row and the column is not needed. So what is now left now? 0, 4, 1, 5. But whatever we do, we take note of this value here. So A11 means first row, first column. So that minus 1, the power of 1 plus 1. First row, first column. So minus 1 plus 1 is what? 2. So minus 1 to the power of 2. But instead of going all this long, minus 1, minus 1, 1, this is the way I always do it. When I take the first one, I do plus A11 is plus, have you? Just put plus in front. Then the row and the column is not, what is now left? What? 0, 4. Please look up because the rest you are going to be the one to do for me. 0, 4, 1, 5. So that will be, you now cross multiply. Don't forget it's always this side man on this side. So 0 times 5 is what? 0. Minus 4 times 1, 4. 0 minus 4, minus 4. Don't forget this one plus plus. I have finished my A11. Now for A12. A12, you know, 1, 2, this is negative. So whatever you do, don't forget that negative is attached to it. So for the negative, A12 is this place, have you? Is that true? Yes. So the row and the column we don't need. So what's now left? 2, 4, 6, 5, have you? Yes. That will now be minus in the 5 times this word. Minus 6 times 4 is a. Eh? 6 times 4. That will be minus. Eh? 24. You got to go say the moment I'm there and there. 1 minus 24, that's minus 14. Because of the minus that is outside here, that place becomes what? 14. That's my A12. So if I want to find my A13 now, I want to find my A13 now. A13 will now be this place, which is plus. Look at this A13, have you? Yes. So the row and the column we don't need. So what's now left? 2061. So that will be what? 2 times 1, 2 minus 0. And that equals to what? 2. So do the rest for me now. Do 2833 for me. Let me check. Manager. You don't get them mama. Eh? Where? Do it for 2833 for me. All right, have you gotten that? What do you have? Just do 2833 so that I call it, I'll write it down. Everyone should try that. Yeah? So you know that when you want to find A11, A12, A13, you should take note of those plus, minus I've told you. You don't know which 833. Have you guys finished?
Yes.
Hmm?
Yes.
So if you have A11, I got A11, I got A12, I got A13. So A21 is minus into this and this we don't need, okay? It says what? A 21. 31 minus 25. 31 minus 25. I hope you guys are following me. So that will now be what? Minus into 15 minus into, that will be 15 plus 2. That will give us what? Is there any 17? 17 outside. You don't see water. I need water. So at that point we have that the value of A13, oh, are they okay? Let me water there. So let's get the value of A. We've gotten A21, A22, A23. Sorry, let me just get my head is very hot. I don't know whether I need deliverance. So we have that point to be so let's get my A22. What did you have as A22? A22, what did you have?
1 minus 2.
So having that, you have A11 minus 4, A12, 14, A132, A21. So A21 was what? Minus 17. A22. 17. A23. 17. A31. You don't solve A31. Nobody solve A31. 12. A32. Did you do that? 8. A33. Minus. So that is my cofactor. Assuming what you guys are having here is correct. That is what we have to get my cofactor. Then for me to get my adjoints, what I do is that I transpose this my adjoint. So my C transpose is equals to adjoint, which equals to transpose means take what belongs to what? To the row to where? Column. Are you following me? So this place will now be minus 4, 14, 2, minus 17, minus 17, 17, 12, 8, minus 5. So that's what we call adjoint. So therefore, if you get adjoint, with adjoint, we cannot be able to find the inverse of a matrix. We can find the inverse of a matrix with adjoints, because the formula for inverse of a matrix equals to 1 over determinant times what? The adjoint. So if you get adjoints, it is more or less closer to the inverse of a matrix. So assuming which is a matrix and you're asked to find the inverse of this matrix, we've gotten the determinant. Did you copy that determinant we had? That matrix we just finished, there was a determinant. Minus 42. So if you are asked to find the determinant of that, if you are asked to find the inverse of this matrix, just like I said, that is the formula for what? Inverse matrix. And what we've done here, we've gotten the adjoint. We've gotten the adjoint because from the given value, we calculate the cofactor. And now the transpose of a cofactor give us what? The transpose of a cofactor give us what? Percentage. No, I mean the transpose give us adjoints. Transpose of a cofactor give us adjoint. The 1 over determinant times adjoint give us inverse. So if our determinant there was, you say it was what? So therefore my inverse matrix will now be equals to minus 42 1 over minus 42 determinant times, which is the determinant, times the adjoint, that is times bomb, minus 4, 17, 12, 14, minus 17, 6, 8, 2, 17 and minus 5. All right. So what we want to do is that okay, let's write the any challenge. Okay, go summary then. All right, now we've been able to get the corresponding value of the inverse of a matrix, which is, if we find that inverse matrix, it is 1 over determinant times adjoint. So let's see how we can calculate other versions of matrix. Let's go to the matrix that involving equations. The inverse matrix involving equation. If they give you an equation and you have to calculate Perhaps you are given to calculate using Grammar's rule. What do we do? All right. Now, application of solving simultaneous equation. So, application of metrics. Application of metrics solving. They say use Grammar's rule to solve the system of the linear equation. You have 4x minus 2y equals to 10. 3x minus 5y equals to 11. For determinants of the coefficient matrix, we have D. So the use of Grammar's rule to solve this equation is, first, you bring out those coefficients. In this case, you have 4 minus 2, 3 minus 5. So determinant of this will be equals to minus 20 minus, that will be plus 6. So that will be minus 14. Have So determinant is not a 0. So you can find the solution of that equation. What we now do there is that first, for x, change over that over data. So that will be equals to, for this is the line for x-axis and this is the line for y-axis. So we are going to replace that x line. What is it? We are going to replace that x line. So this place will now be x, will now be 10, 11, minus 2, and minus 5 will still be there. But changing x, which my x will now be equals to so determinant of this will now be minus 50, 10, 22 divided by minus 14. So that will be minus 28 divided by so let's cancel out this. That is it still. So we got the value of x to be 2. So for y, that y was so for y, the constant term will stay, which is 4, 3. Then I will change that side to what? I'm inviting them whether they will come. So 4 minus 3. You come out this population. So my y will now be equal to 20y over y. That's 44 minus 30 divided by, that will be 44 minus 30. 14 over 14. Does that give us what? We're going to say minus, yeah. That is for y. So that is for 2 by 2. So let's go into grammar through. I'm actually about control. You see that you are sure? Give me that you are sure. So now we have the 2 by 2 variable. So now let's see how we can also apply Grammar's rule to solve 3 by 3 equation. Grammar's rule to solve 3 by 3 equation. So use Grammar's rule. Using Grammar's minus x plus 2y minus 3z equals to 1. 2x plus z equals to 0. 2x minus 4y. So let's see the coefficient of that matrix. The coefficient of the matrix is minus 1, 2, minus 3, 2, 0, 1. So find the determinant of that. Minus 1 into 0, 1, minus 4, 4, 2, into 2, 1, 2, 4, minus 3 into minus 1, this gradient. Minus 3, have 2, 1, 2, 0. Finally, over there. What's the issue? Okay, when I'm there. I don't know what's going on. Go get it. I got to go get it when I. Eh? What is it? What else is there? When you want to go get it, work out. Papa goes. Everybody around the time when I miss right. So if you have minus 1, then this is 0, this 0, 1, 4 minus 4. 2, 1, 2, 4. Minus 3, 2, 0, minus 2. So if you now multiply that, you have what? Okay. Yeah. Now you see that since I've been able to have minus 1, the row and the column of that is here. Minus 2, this and this, we don't need it. Minus 3. Abi?
Yes, sir.
Yeah, very. See, my good students. My good students. So we want to see that value right now. To get the determinant of that. So determinant of that. So that will be minus 1 into, let's multiply this. What do you have? 0 times this one. 0 minus 4, eh? That is 0 minus 4 now. Minus 2 into what? 8 minus 2. Minus 3 into what? Minus 8. Minus 1 into minus 4. Minus 2. What do you have here? 6 minus 3 into what? Minus 8. Is that true?
Yes, sir.
This does now be 4 minus 12 plus 24. Is that correct?
Yes, sir.
Senior man. So 4 minus 12. This, if you add 4 with this, you have 28. 28 minus 12. 28 minus 12 is what? That would be 16. So the determinant is 16. So my A determinant is what? 16.
16.
So when you get 16, why is it not telling here? Why is it different from this? The water is chill. No, okay. But that difference, that value I have is different from the one I got here. Check that determinant again. Check the determinant again from the one I've done. Thank you. Because it's different. That determinant is different from the one I have. Is there any objection? This is minus 1, 2, minus 3, minus 1. Huh? It's correct. Huh? Yeah, 8. The one I do here, I have 10. Minus 1, 2, minus 3, 2, minus 0, 1. Check again, maybe it's this one. This one. So, this one. This one. This one. 2 times 4. This one. I don't see the one you're talking. Which one I don't correct? Okay, but I'm not correct. I'm not correct. But for now, I'm the money again. is 0, 1, minus 1, minus 2, 2, 1, 3, 4, minus 3, 2, 0, 2, minus 4. It is 0, 0 minus. That is 0 minus. Huh?
This point, I will tell you.
Is it from me? Okay. Minus 3. 2, 0, 2, minus 4. And I'm near 3. Okay, from the right up. Okay, the one I'm writing is different from the one here. Okay, I am going to tell you different from what I'm going to. I am going to tell you different from what I'm going to. All right, now, if you are using this determinant here, which place is the mistake here?
That's minus 4. Yes.
This one.
Yes, 0 times 4 is 0. Then minus 4 times 1.
So 0 times 4 is 0.
So there are 2 minus
0. Okay, that place is supposed to be 4.
plus 4.
This place is supposed to be plus 4. That is 4. Eh? This place turned the minus 4. Have you? So from that point we have, so minus 4. So minus 4 plus 4, this is 20. So the A determinant is 8. You have it? A determinant is what? 8. So when I now get A determinant, I can now get that for x, I substitute 0, 0, 1 minus 2 there. So for x, that place 0, 1, 0, 2. Now, other one still remains. If I put the answer in the place of x, I do determinants. Eh? For x, I'll put the answer. I do determinants. Other ones still remain. So that place will now be 2, 0, 4. Was it the place 4 or minus 4? Eh? She was minus 4. So we now find the determinant. That will be 1, 0, 1, minus 4, 4, minus 2 in the word, 0, 1, 2, 4. So you now take 1, 0, 1, minus 4, 4, take minus 2, 0, 0, 1, 2. Now take minus 3, 0, 0, 2, 4. So from that point you have 0 minus minus 4, minus 2 in the one, 0, minus 2. Ever. Later. Well,
And I'm bored of my life and for the copy and board for that also.
So from that point, you have that this will now be what? 0 plus 4 into minus 2, minus 3 into minus 6, minus 4. That will be, this place will be 0. So this place will become minus 2. The first part will now be here 4. 1 into 4. Then plus 4. Let me say this is 4. Minus 2 minus 2 will be 4. Plus 4. Plus. Okay, multiply by minus 2 will be 0. So that will be 4. That place will give us 8. What was the determinant here? 8. So that will be 8 over 8. So that my x equals to 1. So for y, minus 1 will stay 2, 2. You now put 1, 0 to 1, 0 and 2. So I put 1, 0 and 2. Minus 3 will still be there. I found determinant. That determinant will give me minus 15. It's always plus, minus, plus. So this place will now be 2, 1, 2, 4, minus 3 into 2, 0, 2, 2. I'm a good person. So if you now put that value there, we have minus 1, 0, 1, 2, 4, minus 1, 2, 1, 2, 4, minus 3, 2, 0, 2, 2. So this place will now be minus 1 into 0 minus 2, minus 1 into what? 8. 8 minus 2 minus 3 into 4 minus 0. So that will be minus 1 into minus 2 minus 1 into 8 minus 2 is 6 minus 3 into 4. So you have that place to be 2 minus 6 minus 12. 2 minus 6 is minus 1 minus 12. Eh? Minus what? What did you have? Did you try your own? Is that what you have? Minus 16. So for my y will now be equals to So for Z,
we have 1 minus 1, 2, 2.
minus 1, 2, 2.
2, 0 minus 4. And then
1, 0, 2.
minus 1 into 2, 0, 0.
So this will now be minus 1 into
0, 0 minus 4.
now put minus here.
Yes,
Minus 2 into 2, 0. Then plus 1 into 2, 0, 2 minus 4. So that will be minus 1 into 0, minus 2 into
minus 2 into 4 minus 0. Plus 1 into minus 3 minus 2.
so this place will now be here 0, minus 2 into 4, plus 1 into minus 2. This minus 2 here, this place will be 0 now. That is it. Minus 8 minus 2. Where is the 0 from? The last number will be minus 2. Minus 8 minus 2. How do you have minus 0? Is that what you have? Minus 0. So what did you have? Was it not minus 10?
Minus 8.
So therefore Z
0
minus 10 over 8. Oh, minus over 2. Over 2 comes 4 times now. So we're able to get the corresponding value of X, Y, and Z in that equation. All right, let's go to the next subtopic, which is the series and sequence. I'm not going to give me one bomb out there.
280.
Don't look bro. Don't look bro. You don't get it. In series and sequence, we have that sequence is a succession terms in such a way that the terms are related to one another according to well-defined rules. So if you consider this, we have a set. And that set we have like 9, 10, 13, 17, 21, 31, 26, 31, and lots more. So every member of each set is called a term, and the three dot after each shows that the set of numbers are continuous indefinitely. So how do you do that? So let's see how we can apply the context of the end term of a sequence. They give you an end term, they say the end term of a sequence is given by so if you're asked to find the end term of a sequence, and they give you a value like Tn equals to 3 times 2 to the power of n minus 2. 3 times n to the power of n minus 2. You're asked to find the sequence. What do we do? So Tn so the end term of a sequence, we have the following set of numbers that control sequence. The sequence is a succession of terms So a sequence is a succession term in such a way that the terms are related to one another. According to the well-defined rule. Example is 5, 10, 18. One 36. On the C part of that says we have 3, 9, 27, 81, so every member of his set is called a term. So every member of each set so let's see an example of an n term. Brain box. Is it a flow? Huh? Is it a flow? Huh? So every member of the n term But let's be on our feet. Let's be on our feet. Let's just roll our body small. Let's just stand, sit so that you can. You stand and sit. Stand, sit. In uniformity. So we will talk about series and sequence, and I said that a sequence is a succession term in such a way that the terms are related to one another according to a well-defined rule. So I've given you example of numbers, as every number base is called a term because it has a well-defined rule. So example of the n term, example of the n term. The n term of a sequence is given by So we have that the n term of a sequence is given by Tn to the power of 3 times 2 to the power of 2n. Three times 2 to the power of n minus 2. Write down the first 5 terms. Will you give me this sequence? Professor. I don't know. You let me go again. I can get back, I'll go now. Now, the n term of a sequence is given by Tn equals to 3 times 2 to the power of n minus 2. It says find the first 4 terms of the sequence. The first 5 terms of the sequence. So what you do is that you now say that Tn equals to 3 times 2 to the power of n minus 2. So T1 will now be what? 3 times 2 to the power of 1 minus 2. Which means T1 will now be equals to what? Now T2, 3 times 2 to the power of 2 minus 2. That is 3 times 2 to the power of 0. 3, 3. 3 to the power of 2 into 2. T4. T4, that will not be. So T5. T4. T5 will now be 3. 2 to the power of 5 minus 2. Which will be 3 times 2 to the power of 5 minus 2 is 3. That will be 24. First 4 terms of the sequence. Let's see example 2. The first 4 terms of the sequence, which relative is given by Tn equals to 3 plus 7n. Example 2. Find the first 4 terms of the square. Now, you find the first 4 terms of the sequence, whose general term is so Tn so you have the solution to these events, putting n equals to 1. My Tn equals to Tn equals to 3 plus 7n. Put n there, my T1 will be 3 plus 7 into 1, which gives us 10. Now let's get when n equals to 2. Let's get what?
3 plus 7 is 3 plus 14. That's 17.
True there. Is it a draw? So let's see how we can get T2. That's 3 plus 7 into 2 is 3 plus 14. That's 17. And when n equals to 3, T3 will now be 3 plus 7 into 3. And when n equals to 4, that's when n equals to 4. I wrote that big board. That'll be 3 plus 28. That'll be 81. So you can now bring out the first 4 terms. That the first 4 terms are 10, 17. So let's talk about series. So let's try to see how we can understand the context of series, which is addition of terms of a sequence. For example, if you have the first 3 terms of a sequence, yes, ma'am. 10 minutes more. 10 minutes more. All right, please, I was talking about, we have been able to discuss about metrics and determinants. We've done cofactor, we have done the inverse of a matrix, the transpose. In fact, we have done a lot. Even those ones that I cannot see. Am I communicating?
Yes, sir. Yes, sir.
So if you have any question, please, this is the time. Please, it's time for question. Who is questionnaire? What questionnaire? No more. If ask question, don't mind anybody. Anybody will call you questionnaire. If you feel free to ask questions. Okay? You don't have question? Eh? Okay. Maybe. Who did attack you? Eh? Don't mind anybody. Ask a question. You will soon. But you will soon eat.
I said no question. Of course, I don't understand how to solve this sequence.
Remember,
But no question. Now, later, there will be question.
all right, so since there's no question, let's proceed. At least before 6 o'clock, we'll finish. All right, please. We talked about the first terms to be that. Now let's take a look at series. We want to go into series. Today we've been able to do matrix determinants. And series is the addition of terms of a sequence. For example, if the first three terms of a sequence are 3/2, 3, and 6, then the series will be 3 plus 2 plus 6. If the series are 3, hello, what's the problem? If I hear you making noise again in my class, you're going to miss my class for 4 semesters. Is that clear?
Yes, sir.
So please, we talked about series. If you have series A, if you have series like 2, 4, 6, and you want to talk about the value it doesn't mean that we are going to be having the corresponding value as 3, 5, 7, 9, 11 as series. So if you give the question and say, find the series of the first 6 terms, what you do is that you just be fixing values there. Wherever I see n, you put the corresponding value there, and you have your series. That drives off to what we call arithmetic progression. Then the AP, which is also known as linear sequence, is a sequence in which the increase or decrease between the 2 consecutive terms is the same throughout. So they gave you a question, they find the first term and the common difference of the following AP. What do you do? First term is your T1. That's A equals to first term. Common difference is T2 minus T1. There's no big deal about that. Then the n term of an AP, it has a formula Tn equals to A plus A minus in bracket D. So let's see how we can find the 12th term of this AP. They say find the 12th term of the AP find the first term of the AP. The 12th term with the first term and common difference. Whose first term? Whose first term is 6? And common difference. So with that formula we have my Tn equals to A plus n minus 1 bracket D. You can use it to get the 12th term now. N is 12, my D is 3, and my A is 6. You can get the first term easily.
Yes, sir.
Have you?
Yes, sir.
So my A,
6.
whose first term is 6, my N is 12, and my D is what? 3. So my T20 will now be, okay, my Tn12. My A, 6 plus 12 minus 1 difference D. So that will be 6 plus 11. So the answer is 39. Is that clear? So they said we still have 20 minutes.
Right on. You do.
But from there. All right. So we have the 40th term of the linear series. Find the stop. Okay. I'll talk about the value of n, which is 39. So the next question is find the 40th term of the linear sequence. The 40th term of the linear sequence. What do you say? Find the 40th term of the linear sequence. Find the 40th term of the linear sequence. The linear sequence is 6, 11, 16, and 21. In this case, you see that the linear sequence given, my A equals to 6. My common difference is 5, because from here to here is 5, from here to here is 5, from here to here is 5. So, and the number of terms we talk about is 40. So what do we do? Remember my Tn equals to A plus n minus 1 bracket D. So my T40 will now be A, 6 plus n, 40 minus 1, bracket D is 5, which is 6 plus 89 times 5. So that will give us 6. 39 times 5 is 195. You add up with 5, you have 201. So the sixth term, oh, I don't know, So let's see how we can get the 16th term of an AP is 93. The 16th term of an AP is 93. Given that its common difference is 6, find the first and 28th term. Find the first and 28th term. So in this case, they say the 16th term of an AP is 93. That is T16, which equals to A plus 15D. The 16th term will be A plus 15D. And now they say that that term is 93. Given that the common difference is 6, and the first and the 28th term, find the first and the 28th term. So now in that case, my difference is 3. So therefore my first term, that's 93, will now be equals to what? A plus 15 times common difference. What's the common difference? 6. So we are making a subject formula now. So my 93 equals to A plus 15 times. This will give us 90. So at this point, my A will be 93 minus 90. The answer gives us 3. Now, the 28th term, now since we're getting A, to get T28, that will be what? A plus 27D. And my A is 3 plus 27 times common difference. That will be 6. So therefore, that will be 3 plus. That will be 162. That will be 165. So let's see the fourth term. This was also the fourth term of an AP is 15 and the ninth term is 35. Find the 15th term. So we have that the first term of an AP is 15. The fourth term of an AP the fourth term of an AP is 15. The fourth term of an AP is 15. And the ninth term is 35. And the ninth term is 35. Find the 15th term. Find the 15th term. The fourth term of an AP is 15 and the ninth term is 35. So T4 will now be A plus 3D, which is 15. And the T9 will now be what? A plus AD, or the 35. So you have to substitute something there. If you call this equation 1, call this equation 2, you subtract equation 2 from 1, this is gone. 8 times 5D equals 35 minus 15. 35 minus 15 is 10. So now, I can remember log out again, you know. D equals 20 over 5. So the full term of an AP is 15, and I think is 35. So we now get that for. You can now use any of the equation to get my A. So you can say that from What I am wrong. Every box. What I am wrong. Is 3. So my D equals to 3. So with that, we can get our T15 easily. It's very easy. Because T15 will now be A plus 14D. My A is 3 plus 14 into my common difference is 4. Or be 3 plus 16, 41, 414, 56, that is 59. So let's go to the next topic, which is arithmetic mean.
Right on, sir. Right on.
I must have please, maybe go borrow from
Right on, sir.
If you want to target something, there's something you want to arrange. So before 6 o'clock, move. So let's go to, it's for your own good. They can put all this thing in your exams. Seriously. So, arithmetic mean, the arithmetic means of two numbers. Arithmetic mean of two numbers, P and R, is a number of between P and R such that P, Q, R are in arithmetic progression. So if P, Q, and R are in arithmetic progression, then D equals to Q minus P. That's what is implied. So also D equals to R minus Q. So Q minus P equals to R minus Q. So therefore 2Q equals to P plus Q. And now Q equals to what? P plus Q. P plus Q. So Q will now be what? P plus Q over 2. So let's go and see how you can do example 1. So let's get example 1 done. So example 1 says, find the arithmetic mean of 4 and 18. Solution. Now select the arithmetic mean select the arithmetic mean the x. So therefore 4x and 18 are the arithmetic progression. So 4x and 18 are in the arithmetic progression. So that it therefore means that x will now be equals to 4 plus 8 over 2. So 4 plus 8 over 2 will now give us corresponding value 12 over 2. Okay, 4 plus 18. So that gives us 22 over 11. 22 over 2, which equals 11. Now example 2, insert the arithmetic mean between 19 and 35. Insert arithmetic mean between 19 and 35. Maybe I'm 11. I'm 12. Eh? So they say insert example 2. Insert the arithmetic mean between 19 and 35. Solution. Select the arithmetic mean so let the arithmetic mean be P, Q, and R. So if you want to put that P, Q, R in 19 and 35, you're going to have 19 P, Q, R, and 35. So therefore, we say that from that point, my T1 equals to 19, and my, which is equals to A. So therefore, my T5 will now be A plus 4D. Which is 1, 2, 3, 4, 1, 2, 3, 4, 5. Which is my A is 19. That will give us 19 plus 4D. That is 35 equals to that. So you can find 4D. You can make 4 the subject for formula if I'm finding. So let's find the. So therefore, let's say 35 minus 19 equals to 40. 35 minus 19, that will be 16. 16 equals to 40, and this will now be 16 over 4. So this will now be equals to what? 4. So when I get D, I can now get other ones, respectively. So that my T2 equals to A plus D, and we got our A to be 19, all is 4, that will be 33. And T3, you know that T2 is P. Q equals to T3, that will be A plus 2D. And my A is what? 19 plus 2 times common difference is 4. That will be 19 plus 8. That's 27. Then R, A plus T3, which is what? 19 plus 3 times 4. 19 plus 12, that's 31. Now let's talk about sum of the term in an AP. Sum of term in an AP. Sleep, Lord. I won't go sleep. I won't go sleep. I won't go sleep. Eh? So let it go now. Even when I get complain. These people really complain of sleep.
I'm encouraging you.
Hmm?
I used to.
All right, now, since we have been able to get, let's talk about the sum of the term in an AP. Sum of term in an AP. Just dedicate your time to learn. I'm here to teach you. I have what it takes to give you what you want. So let's flow. So sum of the term of an AP, the sum of term in any AP is the addition the sum of term in an AP is addition of all terms involved in the particular AP. Then Sn equals to what? N over 2 in the 2a plus n minus 1 bracket D. Or you can say Sn equals to what? N over 2 A plus L, where L is the last term. So if you can use this formula, you're able to get to solve whatever formula you want to. So let's see how we can use it. So let's go. They say find the sum of the first 25 terms of the sequence. Find the sum of the first 25 terms of the sequence. 11, 15, 11, 15, 19, 23, and 27. A equals to 11, B equals to 4. So you have 2A plus n minus 1 bracket D. So therefore my S25 S25 will now be 25 over 2 so that will now be so let's get example 2. They say the 9th and 22nd term of an AP the 9th and the 2nd term of an AP are 29 and 55, respectively. Find the sum of its first 60 terms. The 9th term, so starting with T9, A plus 8D, this is 29. 20th term was 1. So we have that equation 2 minus 1 half, that will be A plus 8D equals to 29. A plus 21D equals to 55. This minus is gone. 21 minus 8. 18D. So far you have 26. You will now make 26 over 11. So you have 26 over 11. Okay, you don't want to go now. Eh? What is it? Okay, T9 and T20. T22. But you should know that Sn equals to n over 2 in the 2a plus n minus 1 bracket D. So if you now multiply that, you have that this cancel out, there's 30. So that will be 26 plus 59 over 2. That will be 80 over 144. So we'll be able to get 4, 3, 20 in that particular question. Now let's go into geometric progression. That's GP. Have you heard of GP before? Have you heard of GP before?
Yes,
Yeah. So geometric progression. I don't know. And I will maintain that is your passport. The geometric progression also known as exponential sequence This is a sequence in which only two consecutive terms differ by a constant. Only two consecutive terms differ from the constants. So let's go to example of a GP. So we have A, (16, 24). Now let's see example 1. It says find the first term and common ratio of the above geometric progression. Find the first term. Find the first term and common ratio of the above. So you have that geometry to be 6, 1854.
Yes, sir.
So from there you see that my R will go to 16 over 8 or 18 over 6, which gives us 3. Are you following?
Yes, sir.
So that is to say, you say 54 over 18 will give you 3. You have finished that one there. Before we go, let me just finish this AP and GP so that we can know at least I've covered a long topic with you guys. Project time. So we have 13. I guess A equals to 16. And give a, what time did I say she said we can't sleep? What time did I say she can't sleep?
So
What time did I mention? Not I remember. May have bombs and may bomb now. Abandia, you don't want that if you're not on it. What I got, I have 2 minutes. I got no pumps, Bob, no, I'm going to get them on Saturday. Bob, because I'm going to be fair with Bob. I'll say, we're going to. Is that given the geometric progression 5, 10, 20, 40, and 80. Find it. Find 8, 9, 10. To the end term.
Yes, sir.
So you have to find the end term. In that question, they gave you A, they gave you R, common ratio. So to find, this is going to be TRN. So T9. This is going to give us T. So T47 will be 5 times. So we are going to fix up that value. Divine T47.
You complain, okay, you make
minus 10 minutes time. All right, so now we want to find the value of, we've been able to get Tn. Now the n term of a GP with first term and common ratio is given by that. So let's see how we can fire on at least before 6 o'clock we can leave. Yeah, let me change. Okay. So, example number 2. The first term of a GP is 7. While the common ratio is 3. Find 11 10. A equals to 7. Are you following me?
Yes, sir.
Since only you are following me, what happened to your student? Are they not coming to school? Are they not coming to school? They have not paid their school fees. So multiply 7 times 59049. Okay, 413. Example 2. Let's go check them. All right, now okay, come on, Raul. Okay, now we want to find the corresponding value. If you're able to get that value, 413,145.
Is that the third term?
I depend now, sir. That's a shortcut of third term. So on that note, since we're able to get the third term and the ninth term, what we do there is that we now say that my T3 was AR2 was a 54. So with T1 and T2, we can divide through by equation 2 by 1. So dividing, we can get the value. So you divide equation 1 we divide equation 2 by equation 1. I'm about 318. I'm moving out of there. I can maybe tell you that. Yeah, I'm going to